Do you know about the Soundex algorithm? If you are developing address databases, you absolutely should. Hi, I'm Philip from codekabinett.com, and today I'm going to talk about the Soundex algorithm. And without further ado, let's watch a quick presentation I prepared. So, the Soundex algorithm was invented in the early 20th century, and it is a phonetic algorithm. That means it deals with how language sounds. And the intention of the Soundex algorithm was to create an identical representation for homophone words. That means if, for example, the name Mark, if you just listen to the name, you cannot distinguish if that is spelled with an C at the end or with a K at the end. It's impossible to separate these two different spellings of the word. And the Soundex algorithm wants to find a unique representation just for this sound, regardless of the spelling. And it is somewhat language dependent. It was originally designed or created to work with English words and particularly names. And the closer a language is to English, the better the algorithm will work. But it might need some adjustments to work with different languages than English. I will show you an example in a minute. So the representation of the sound of a word is formed by taking the initial letter of the word and then computing 3 numerical digits that represent the rest of the word. And the primary use case for the Soundex algorithm is a fuzzy name search. It was used by the United States Census to analyze historical census data where names might have been spelled differently in the records despite meaning the very same person. So they used the Soundex algorithm to do a fuzzy search, ignoring spelling differences, minor spelling differences. And today, the primary use case is for any case where you are communicating names via the phone. Think a call center application where a customer calls you and says to you, hey, my name's Anderson and I'm very angry because my order has not been delivered yet. And instead of asking Mr. Anderson, can you please spell your name exactly, you just type in what you heard into your customer search form, and the Soundex algorithm can then still find the customer even if the spelling was not exactly correct. Most modern database systems have a built-in Soundex function that implements that algorithm already, and you only need to use that. Unfortunately, Microsoft Access is not one of them. So I will show you how to use the Soundex algorithm in Microsoft Access. But first, look at a couple of examples, and my name is very well suited to demonstrate the problem. This is the correct spelling of my name with 1 L in the middle and 2 P at the end. And the Soundex code for that is P410. But sometimes people omit the final P and write my name incorrectly, but the Soundex algorithm of that incorrect spelling is still P410. And the same if they add in an additional L in the middle, or if they even add the P at the end and another L in the middle. It doesn't change the Soundex. But the biggest weakness of the Soundex algorithm is that initial letter. So if somebody uses the much more modern spelling of the name Philip with an F at the beginning, the Soundex algorithm will fail to find the different classical spellings of the name because the initial letter is different. And that is definitely the biggest weakness of that algorithm. But I can't do more than warn you about it. Now, if you want to implement the Soundex algorithm, you can download ready-made implementations from the internet, but not only in this case, but always be very, very careful when downloading stuff from the internet. When I prepared this video, I intended to just download a ready-made VBA implementation of Soundex, use that, of course mention the original author of that function at the credits, and I'm done. And it didn't work out that well. I downloaded 5 different implementations of Soundex and VBA, and 2 of them were plain wrong. 2 of the remaining were correct, but they looked nearly identical, but were published by different persons. So I thought, well, either the one person wrote that code and the other copied it, or the second person wrote the code and the first one copied it. And I don't want to use any code in my public demos where I can't really credit the original creator. So I discarded them. And the final implementation was also working correctly, but it was working slightly different, not really wrong, because there are slight variances of the implementation of the Soundex algorithm. And I would say it was correct, but it was working differently than, let's say, the implementation in Microsoft SQL Server or Oracle, which I think should be our references here, with limitations. I'll talk about that in a second. And a major problem with those Soundex implementations were that they were written by people using primarily or only English language. And if you gave those implementations some completely foreign input, which was Unicode input in, let's say, a Cyrillic or an Asian language, then they totally fall apart and did not work at all and completely crashed. So I ended up writing my own Soundex implementation, and I'll show you in a second. Before we look at actual implementations, just a few thoughts about adapting Soundex for different languages. For German, the Soundex algorithm works reasonably well in its original form. I used the Oracle and Microsoft SQL Server Soundex implementations, which are the plain basic English versions of Soundex with German customer names for many, many years, and there was not a major problem detected by the users. So you can use the original Soundex also with German, and I suspect probably also with Spanish or French, but I'm not an expert on these languages. But if you want to have better results for German, you need to adjust the Soundex function. So you would need to treat our umlauts in German as normal vowels. That is pretty obvious, and it's a minor change. And the next, and that is in my opinion the most important one, you need to treat our sharp S as a normal S in processing the word for Soundex. If you make these 2 changes, the results of Soundex for German words are already pretty good. You should add a couple of other ones. I listed them here just for completeness. If you visit the German page for Soundex on Wikipedia, there are some guidelines in explaining what you should change and why you should change it. So, but we are quickly switching over to a demo. So I created a demo in the Northwind database because it's already a database with customer data in there, but it doesn't really matter. First, let's look at my implementation of the Soundex function, and that is pretty straightforward here. It just takes an input term, which is a string that would be the original word or name, and it computes the Soundex and returns that as a string. Now, for performance reason, I convert the input string into a byte array, and then I kind of loop through this byte array, provided there was any input at all. I just loop through that byte array and process the characters individually, and I use, which is slightly weird, I use the VB key codes, which are constants, in my code to analyze which letter is are we actually processing at the moment and how should that be converted. And I use constants for performance reasons again, so that I don't need to have a function call to the ask function to get the ASCII character value for each character, or vice versa, transform it back. And these constants are already built in, so I used it because I was too lazy to define my own. So, one important thing that is not the function directly, but either associated with it, it's testing the function. And if you use my function or any other function you found on the internet, or one you wrote yourself, you should definitely, absolutely definitely test it with some sample input. And if you visit the very short description page on the Soundex algorithm on the American Archives and Records Association, I will put a link in the description. They kind of maintain the official Soundex standard. You will also find a list of examples which shows how the Soundex value should be computed for them. And you should use those examples as test cases to verify that your implementation actually works as intended. So let's look at practical uses of the Soundex function. First here, I wrote a simple query here, and it applies the Soundex to the last name column in the database, and it compares that to the Soundex value of a search criteria I just entered. And while this works, I absolutely discourage you from using it this way, because applying a function to a database column will force the database engine to process each row in your table to compute the results of the function, and that will kill performance. If you're interested in that topic, I'll put a link somewhere up here to my performance tuning video where I discuss these topics in much more depth. For now, just keep in mind, don't use a function call on a database column if you can avoid it. So, nevertheless, we are going to run this function and enter the name Anderson here and run it. And now, oh, sorry about that. Now you see this found two people, one that has the exact same spelling as I typed in, but it also found another person where there is the name spelled with an O at the end. So to combat that performance problem, I made a slight adjustment to the table structure here. See, I added a column company Soundex and a last name Soundex and also first name Soundex. And in these columns I store the Soundex code value for the company name, last name or first name in the database. So I don't need to compute it for every record when I want to search it, because it is already there and it is stored. So to compute the initial value, we need an update function that processes our data in the database, and this is just a plain simple function here, just updating the Soundex column with the result of the Soundex function call applied to the original value of that column. And we do that for company, last name and first name, all the same for all the data. Of course, if you got a huge database, this query will run for a while because it touches every record, but it does it only once during setting up your Soundex logic in your application and not on every search operation. So we should quickly run that, and of course this is very fast here because I only got 44 records in my database. So when you use this approach, you should keep in mind that you need to calculate the Soundex values for each record that is entered into the database or that is changed. And you can easily do that by adding the Soundex columns to your data entry sheet and then provide an VBA function or VBA procedure for the before update event of your code, and in that event you just update these additional columns with the entered with the Soundex value for all the entered data. Quickly look at that in practice. We go to a new record here and say this is the test corp as company, and it doesn't really matter. And the last name, let's use the German Müller as last name, and the first name is actually Mark. And now we save this record, and you see instantly here the Soundex values are computed for these values, and the new record is supplied with the Soundex values. Now let's take a quick look at the Soundex data here in the database. These are my Soundex columns, and they contain the data. And if we let's look at first name first, and this one here is interesting. So we got several identical Soundex values here for the name John. And you see, it doesn't matter if the name John is spelled with an H or without it, it will always produce the same Soundex value. And we got a bit of an anomaly here with the Jason, which probably misses an A, but if, well, it is calculated, it has calculated the same Soundex value as John. That is probably not what you intend, but it just happens that way because all the other parts of the name are eliminated, and so it gets the same Soundex value. So with that, a bit of warning, you should never use the results of the Soundex function for automatic processes to update your data where the computer makes the decision to match a record and then do something with it. It is meant to aggregate results and present it to a human for further consideration, like in a search form where you display multiple records that match the search criteria. Then it doesn't really matter if there are slight errors and inaccuracies in the search results, because the user will have the final word and decide what happens here. So I also applied the Soundex function to the company name, but that is only slightly useful. You see here is a company of fools and a company of foodies and a company of gourmets and even a company of lunatics, and they all get the same Soundex value because the name, the word company already uses up the 4 characters of the Soundex value, and what comes after that is not taken into account. So you can use Soundex for company names, but it will not produce the best results. Now look at another query I created for the use with the Soundex function, and I switched to SQL view here. No, we don't zoom that in because you won't see much. And let's concentrate on just this line here, because the rest is just making sure if I don't enter data for one of the search terms, it still shows up, and the rest is not really important. The important part is I take some input, which is a parameter to this query, apply the Soundex function to the input the user entered, and compare that with the stored Soundex values in the database. And that doesn't suffer from performance problems because the computation is only processed once for the user input and not for all the records in the database. So I run this query and I don't enter any last name, and now I just enter John as a first name, and you see in the results it finds all representations of the sound John in the database, just as I showed you a second ago. So we have looked at the practical considerations of implementing Soundex. Now, just a couple of words if you consider to use the Soundex function. I said there are different implementations around. That means that you should always consider the Soundex values of the data stored in your database as an internal value to your application. If you get, if it ever should happen that you get data from another application that is exported and that includes the Soundex values, you should probably discard those that were pre-calculated and recalculate them with your own implementation of the Soundex algorithm, because there are slight variances. And the Soundex implementation that I included here in my sample, and you will get the sample file for download if you like. I'll put down a link in the description. Regardless which you use, you should be aware how it works, or at least you should make sure that all your application or all applications that work on the same database use the same Soundex algorithm. My implementation is compatible to SQL Server and Oracle, but MySQL and MariaDB and probably also Postgres use a slightly different implementation of Soundex, where there will be different results computed for a small number of input strings. But if you only keep your Soundex data local, that is not a problem at all. You can enhance the function, say for German, for French, for Spanish, or for whatever language, and it will still work as long as you keep it inside your application and don't give it to other people who might use a different implementation. And finally, one word on foreign languages like Cyrillic, Arabic, and whatever languages there might be that use Unicode data to represent the text. Unfortunately, The Soundex functions do not work with those. My function fails gracefully and outputs a question mark followed by 3 zeros. So there's no error and there is a technically valid output, but you cannot use that for comparison because every input in Unicode will create the same output. If you have foreign names like Asian non-ASCII names or non-ANSI names in your database, then you cannot really use the function and need to exclude these results from the search results. Okay, I think that's it for today. Thank you very much for watching. Please consider subscribing to the channel if you like this content, and see you next time. Bye bye.